Starship mega rocket, the world's largest and most powerful, was sent into space by SpaceX on the 14th of March, 2024. It reached orbital speed in a historic third test flight from South Texas. It was a glorious event. Hundreds of spectators, rocket launch chasers, and fans gathered along the shores of South Padre Island and nearby areas to witness the flight of the biggest rocket ever built. Starship lifted off at 9:25 a.m. EDT from SpaceX's manufacturing and test launch facilities near Boca Chica Beach. According to the company, the launch happened on the 22nd anniversary of SpaceX's founding in 2002. Unfortunately, neither the Starship vehicle itself nor the Super Heavy booster managed to survive all the way through to the intended splashdown. And still, SpaceX representatives claimed that the test flight achieved quite a few of its main goals during the flight. It went like this. The dim morning sky was brightly lit by the ignition of Starship's 33 first-stage Raptor engines. Soon, the vehicle was shrouded in plumes of dust and smoke. A mere seconds later, the 400-foot-tall rocket lifted off the ground and started its climb skyward. This launch, Integrated Flight Test 3, was Starship's third test mission. The first and second launches didn't end well. Both vehicles detonated before completing their goals. On the bright side, data collected by those first flights helped SpaceX engineers prepare Starship for the successful launch. The improvements included the implementation of a hot staging technique. When it's used, the upper stage engines begin firing before the spacecraft's first stage booster, the very Super Heavy we spoke about earlier, separates completely. This hot staging maneuver turned out to be a success. But back to the mega rocket's launch. Already high in the sky, Starship's two stages separated. It happened around 2 minutes and 45 seconds after the liftoff. The 165-foot-tall upper stage spacecraft continued onward to space. As for Super Heavy, it began preparations for redirecting its trajectory. The post-staging burn was supposed to be followed by a landing burn above the Gulf of Mexico minutes later. But apparently, the engines of Super Heavy didn't reignite as planned, which, sadly, led to the loss of the booster. Specialists from SpaceX are going to go through data to find out the reasons for this issue. Starship is built to be fully reusable. SpaceX plans to land and relaunch Super Heavy boosters, just like it does with its Falcon 9 rockets. In the future, two large arms attached to Starship's launch tower will be catching Super Heavy after it returns for landing. This time, though, it was supposed to splash down in the Gulf. But what happened to the upper stage of the spacecraft? After separating, it continued flying for some time. But it didn't even try to go into a full orbit. Instead, the space vehicle entered a suborbital coast phase while soaring above Earth. SpaceX hoped to use this phase to demonstrate two of the spacecraft's flight systems: the reignition of the Raptor engines and the transfer of cryogenic fuel between tanks. Afterward, the spacecraft was to splash down in the Indian Ocean a bit more than an hour after launch. Unfortunately, SpaceX lost contact with Starship during re-entry. SpaceX has lots of plans that involve Starship. For example, the company hopes to use this space vehicle to launch the next generation of Starlink internet satellites. Equipment needed to build another launch tower has started to arrive at the site. Infrastructure for Starship launches from NASA's Kennedy Space Center is also well underway. The thing is, the faster the company will be ready for the next launch, the sooner NASA will give Starship qualification to carry astronauts. Perhaps reaching NASA's ambitious Artemis 3 timeline might be a bit unrealistic. But SpaceX is no stranger to fast launch cadences. The company's Falcon 9 rocket has been breaking its own annual launch record year after year.
Usually, when we look at the photos of astronauts in space, we can see that they're sort of attached to the spacecraft. But there was one brave astronaut who took a wild step into the great unknown without any safety line connecting him to the shuttle. This brave man was Bruce McCandless, and he did that stunt back in 1984. How did he come back, you may ask? He did this cool trick using a nitrogen jetpack, which NASA called the Manned Maneuvering Unit. At first, he tried out some test maneuvers in the Challenger's payload bay, and only after he made sure it was all right did McCandless decide to go for it and glide a staggering 320 feet away from the shuttle. A bit of sad stats here. Out of the 430 people who have made the leap into space, 18 have sadly lost their lives, which gives us a fatality rate of just over 4%. With these numbers, it's safe to say that space shuttles are the least safe means of transport out there. Duh. Alright, let's make it a tad brighter. If we crunch the numbers a bit better, we can get a smaller percentage. But how? Well, 4% is a bit misleading because when we count, we take all the space flights. However, some people flew several times, which reduced the probability. With over 600 seats filled across 113 shuttle flights, the true fatality rate for shuttle missions is actually closer to 2%. Let's test your general knowledge now, shall we? So, what was the first living thing ever sent to space? If your answer is a monkey, you aren't right. Those who said dogs, sorry you guys, but it's not correct either. On the 9th of July, 1946, fruit flies became the first living creatures to make it to space during a suborbital V-2 rocket flight. Then, on the 20th of February, 1947, these little guys safely returned from their journey, opening the door for future human space exploration. Before, we sent to space mammals like the rhesus monkey, Albert II, in 1949, or the famous space dogs. Scientists spent a lot of time studying fruit flies to see how they reacted to radiation and the conditions of space travel. Researchers started using fruit flies for experiments back in the 1910s. Guess why? Because we humans share a lot of genes with these yucky pests. Imagine hearing some creepy music all of a sudden, when there's nothing but darkness around you and nobody is there to help you. Right, now imagine how elevated this experience was for astronauts who heard some creepy music in their space shuttle. Months before the moon landing, Apollo 10 astronauts were orbiting the moon, testing equipment, when they heard strange audio noises. Astronaut Eugene Cernan noted the eerie sounds, joking they were like weird music. At that moment, the astronauts didn't have contact with mission control. They were over the moon's dark side. Although the noises resembled something from a sci-fi film, NASA downplayed them as they were focused on the astronauts' mental health. Despite years of speculation, the source of the sounds remains unknown, with theories ranging from radio interference to charged particle activity. Cernan later remarked that they didn't take it seriously and didn't report it after the mission. Chances are, we've already received messages from new friends from other galaxies, but we just failed to understand them. In August 1977, some astronomers using the Big Ear radio telescope at Ohio University picked up a strange narrow-band radio signal from the constellation Sagittarius that lasted for 72 seconds. The signal buzzed at a frequency of 1,420 megahertz, which is significant because it matches the natural emissions from hydrogen. This frequency had been flagged by scientists almost 2 decades earlier as a likely choice for extraterrestrial civilizations trying to reach out to us. They dubbed it the WOW signal after one of the astronomers wrote "WOW" on their printout. We've never heard that signal again, and no one has been able to explain its origins satisfactorily. After spending about a month in space, astronauts start losing quite a lot of skin from the bottoms of their feet, especially those tough calluses they've built up over time. One astronaut even called mission control in a bit of a panic when he noticed a chunk of his heel drifting off in zero gravity. But no worries, as the old calluses peel away, new ones spring up from the tops of their feet. They need that grip to hold on to all the restraints, kind of like airborne trapeze artists. Going number 1 and seeing blood is as scary as it sounds, and yes, in the weightlessness of space, blood doesn't settle in the lower body in the same way it does on Earth. This can lead to some alarming situations on board. Natural urges are universal, regardless of location. There are two main reasons why astronauts are unable to use traditional toilets in space. First, water is an extremely valuable resource aboard a spacecraft. Second, there's no gravitational flow of water in space. The drinkable water on a space station is contained in pouches and is used accordingly. In a weightless environment, a specialized device with suction and disposable bags is used for waste collection, with the storage being replaced every 10 days. Additionally, spacecraft are equipped with complex systems designed to recycle and filter liquid waste, converting it back into usable water for the astronauts' daily needs. As if that wasn't enough, spending an extended period floating around in space brings another challenge. The body may lose its bursa sacs, those handy little cushions that sit between our hip joints. While this may not pose an immediate issue in the zero-gravity environment, returning to solid ground can turn the simple act of sitting down, whether in a chair or on a toilet, into a real struggle. The fluid shifts that contribute to blood-related issues don't stop there. They can also wreak havoc on astronauts' sinuses, creating a constant feeling of congestion. It feels like living in a stuffy room all the time, where relief seems just out of reach. Thus, the challenges of long-term space travel add up, making the experience as daunting as it is thrilling. Another challenge astronauts run into is vision loss, also known as ocular syndrome, which sounds all sciencey. While the exact cause is still a bit of a mystery, it's thought that extra pressure on the brain can mess with both the retinas and optic nerves. And here's a fun fact: it mostly affects guys. By the way, you might assume that shutting your eyes in space means it's pitch black, but that's not the case. Because of high levels of radiation, astronauts can still see bright lights when they zip through certain parts of their orbit. It's a pretty strange phenomenon that keeps them on their toes, even with their eyes closed. Switching gears, let's talk about bone health in space. It turns out that being weightless can really take a toll on astronauts' bones. Like, they can lose up to 2% of their bone mass every month, which is pretty wild. But the good news? They've come up with new exercise routines that help fight off that bone loss. So, while space travel definitely has its challenges, researchers are working hard to keep astronauts in tip-top shape as they explore the universe. The Big Crunch is a cool theory about how the universe might end, and it's basically the opposite of the Big Bang. So, imagine the universe expanding for ages, but then it hits the brakes and starts collapsing in on itself, maybe even forming a huge black hole. Scientists are looking into this by checking out the universe's density. If it's too dense, such a collapse might really happen. At first, people thought that gravity would eventually take over and stop the expansion from the Big Bang. But then we found this mysterious thing called dark energy, which is actually speeding up the universe's expansion. Because of that, it seems like the Big Crunch is pretty unlikely. Right now, the evidence shows that dark energy is here to stay, so the universe will just keep on expanding forever.
It may sound unexpected, but how long could a nuclear submarine last in space? Here's a spoiler alert: not very long, but the reasons are likely to surprise you. Unlike what you might think, the submarine wouldn't just explode or fall apart into pieces. Submarine hulls are built to withstand insane pressures, between 50 and 80 atmospheres of external pressure from deep ocean water. So it's quite easy for them to contain 1 atmosphere of internal pressure in space. Then there's this thing. Watertight seals aren't completely airtight, but submarines can keep the water out under immense pressure. It means that air wouldn't be escaping into space too quickly. In other words, your submarine wouldn't leak air all over the cosmos. Okay, how about carbon dioxide buildup? Surprisingly, it wouldn't be an issue either. The thing is, submarines use CO2 scrubbers that can run for a long, long time, as long as there's power. But oxygen is another story. In usual conditions, nuclear subs extract oxygen from water. In general, one can easily imagine a device that will work like plants. With the help of external electricity, oxygen will be released from carbon dioxide. Overall, this doesn't seem like a big problem. But if we didn't add such special devices to the submarine, it would only have enough oxygen to last a few days. Then, this supply would run out. But even before that, a bigger, more immediate threat would arise: overheating. Most people are sure that space is insanely cold, and that's partially true, but it should be noted that it is one thing to interact with something slightly cold but conducts heat well, and a completely different thing to interact with something very cold, but without the ability to give off heat to it. It's like touching metal and foam. The foam will feel warm regardless of its temperature. Space is similar. It has an extremely low temperature, but it might feel very warm. So, without air or water around to absorb and carry away the heat of the submarine, it would only be able to cool down through radiation. For normal space stations, this is not a big problem. For this purpose, stations like the ISS use special coolers that radiate energy into space. But this method is only sufficient for cooling small heat sources at space stations. But submarines generate much more heat. They simply aren't designed to operate in space. They have to cool down with the help of seawater. But in orbit, there's no water to carry away the heat. So the heat generated by the submarine, especially from its 200 megawatt nuclear reactor, would become a problem very fast. You see, civilian nuclear reactors are only about 50% efficient, which means that half of the reactor's energy is lost as heat. If the same applies to the sub, around 100 megawatts of energy would be building up as heat inside the sub. It is about 1,000 times more than the total power of the ISS. Without seawater to cool it down, the sub would start heating super fast, and within an hour it'd be too hot for humans to survive inside. And not long after that, the nuclear reactor would overheat and melt down. Now let's say you somehow managed to send your submarine into space, and now you gotta get it out of orbit. How could you do it? To leave orbit, you'd need to slow it down enough to re-enter the atmosphere. Submarines do have rockets, they are just not attached to them. So, theoretically, if you turn those missiles around and launch them in reverse, they could help slow down the submarine. But there, you'll encounter a new problem. Submarines don't have heat shields like spacecraft, and without this protection, the sub would simply burn up on re-entry. And since submarines aren't built to be aerodynamically stable at hypersonic speeds, it would start tumbling uncontrollably while re-entering, breaking apart in the atmosphere. The debris would either disintegrate in the air or crash into the ground at terrifying speeds. Could you survive re-entry inside a submarine? Unlikely. If you somehow managed to strap yourself into a special acceleration couch inside the right corner of the submarine, there would be a tiny chance of survival. But then you'd need to jump out of the wreckage, hurtling toward the ground with a parachute before it hit the ground. You'd also need to disable the missile detonators before trying this stunt. Otherwise, you'd have way bigger problems than overheating. All in all, nuclear submarines are great for deep-sea missions, but absolutely not efficient in orbit. Running out of oxygen, overheating from the reactor, lacking rockets to safely deorbit, obviously submarines are best left under the waves.
The two Voyager spacecraft have had a great track record. They took photos of such planets as Jupiter, Saturn, and Neptune, and then just kept going, beyond the outer edge of the solar system. At the moment, Voyager 1 is more than 15 billion miles away from our planet, and is still transmitting. Surprisingly, it takes only 22 hours for the signal to travel from the spacecraft to Earth. But how is it even possible to send signals for such unimaginable distances, considering that the satellite's processor is weaker than the processor from car keys? Both Voyager spacecraft use 23-watt radios. This is higher than the 3 watts a regular phone uses, but it's still considered to be a low-power transmitter. Interestingly, because of the ginormous distance, the phone's 3-watt signal, traveling around 100 miles on Earth, is billions of billions times more powerful than a 23-watt signal coming from Voyager. By the way, large radio stations on Earth transmit at tens of thousands of watts. This puzzle is easy to solve. The key to receiving the signal is not the power of the radio, but a combination of 3 other things. First, there must be very large antennas. Second, there must be directional antennas pointing at each other. And third, we need radio frequencies without tons of human-made interference. The antennas the Voyager space probes use are indeed very big.
Have you ever seen satellite dish antennas some people have in their yards? They're typically 6 to 10 feet in diameter. Well, the Voyager spacecraft has an antenna which is 12 feet in diameter, and it transmits to large antennas on our planet. Earth antennas and the Voyager antenna are pointed right at each other. The centers for receiving signals from Voyagers located on our planet are positioned at an angle of 120 degrees to each other. This allows them to provide Voyager 1 coverage at any time of the day, no matter what Earth's position is in relation to the spacecraft. These receiving stations are situated in Australia, Deep Space Network Station in Canberra, the USA, and Spain. Let's try to figure out how communication works on Voyager 1. To do so, we need to discuss the design features of the space probe's radio reception equipment and the computer system serving it. We'll start with AASC, which stands for the Articulation and Control Relationship System. Its main purpose is to send data about Voyager's position in space and its route back to Earth. High-gain AASC antenna is always directed toward Earth to help amplify the weak signal. By the way, once it broke down, but specialists repaired it by updating the program.
Voyager's signal strength keeps decreasing, causing the data rate from the spacecraft to Earth to decrease too. In 2017, for example, the probe's signal strength was many times weaker than the signal of a conventional FM receiver. Luckily, modern technology has seriously improved the sensitivity of the receiving antenna network. The increase in signal gain is achieved by capturing the signal from Voyager by a station on Earth to provide stable communication between the probe and Earth. The wave frequency should equal 2114 MHz. As for reverse communication from our planet to Voyager, it occurs when the space probe receivers are synchronized with the frequency of the uplink carrier by phase. The probe converts it into a two-way downlink carrier signal and sends it back to Earth. Not so long ago, NASA announced that Voyager 1 had started experiencing problems with determining its position in space. The data the spacecraft was sending to Earth had nothing to do with its estimated trajectory and flight speed, but specialists at NASA managed to figure out where the failure was. The AASC had started sending data through an onboard computer that had stopped working years before. It was this computer that had been corrupting the information. Once experts realized what the issue was, they commanded the AACS to resume sending data to the right computer. At the moment, Voyager 1 seems to be still traveling along its initial path, which is indirectly indicated by the stability of the radio signal emitted by the probe. Speaking of Voyager's journey, gravity assists their maneuvers. When they were launched, all the giant planets were conveniently located in a relatively narrow region of the solar system, and the spacecraft managed to visit all of them at once. Both Voyagers are carrying time capsules intended for any intelligent extraterrestrial civilization. These capsules include greetings in 55 languages, as well as different sounds and images. By the way, Voyager 2 is now over 40 years old and is the most distant human-made object. And shockingly, scientists are still fixing its software issues.
Picture this. You're planning your dream holiday, but instead of going to a tropical beach or a bustling city, you're thinking about going to space. Imagine yourself floating, weightless, looking down at Earth from a whole new perspective. The beauty and wonder of our planet become even more evident when you're viewing it from a distance. And now, this dream can come true. Yes, you heard that right. Space tourism. Space tourism is something that has fascinated people for generations. This idea has been around for almost 20 years. We've seen it in movies and read about it in stories. But now, thanks to advancements in technology, it's finally becoming a reality. The first space tourist was a businessman named Dennis Tito. He visited the International Space Station in 2001. Sounds incredible, but here's the catch. Tito's trip cost a mind-boggling $20 million. That's a lot of money, and it made space travel seem like a dream that only the super rich could afford. And it's true that space tourism can be quite expensive. But a lot of time has passed since that day, and now space tourism is becoming more attainable for people who aren't billionaires. Of course, the industry is still in its early stages, but the demand for it is skyrocketing. Pun intended. Experts believe that it will continue to grow at an incredible rate of around 40% every year from 2023 to 2030. So, with all this in mind, let's talk about what awaits us in the near future. There are different types of space tourism. First up, we have suborbital spaceflight. It's the trip where you reach an altitude of over 300,000 feet, which is way higher than any airplane can go. In fact, it's so high that you cross a special line called the Kármán line, which marks the boundary of outer space. How cool is that? So it's basically like a quick jump into space and back. So let's talk a bit more about suborbital spaceflight. Imagine you want to go on vacation to Sydney, but you live in London. Normally, it would take you about 22 hours to get there by plane. That's a really long time to sit on a plane. But guess what? Scientists and engineers are working on a new way of traveling that could make the journey from England to Australia super fast and exciting. Suborbital space trips could be used for quick travel between different cities on Earth. Instead of flying in a regular airplane, you would hop on a spacecraft that can go really, really fast. According to a recent study, in the near future, it might be possible to fly from London to Sydney in less than 2 hours. Just imagine how amazing that would be. You would zoom up into space, see the Earth from above, then come back down in no time at all. What an adventure! This study, conducted by the UK's Civil Aviation Authority, was all about understanding how our bodies react to trips outside Earth's atmosphere. To figure this out, the researchers needed some brave volunteers. They recruited 24 healthy people between the ages of 32 and 80. These volunteers were taken to a special training facility called an RAF centrifuge in Cranwell. A centrifuge is a big machine that looks like a giant spinning chair. The volunteers were sat in there to experience a simulation of spaceflight. They were spun around, and their bodies felt the pressure and changes in gravity that happen when you go into space. Almost everyone handled the simulation pretty well and quickly returned to normal. One person even briefly lost consciousness, but it was because of the gravitational forces, and they recovered soon after. Now, this study found some surprising things. Many people think that you have to be really fit and young to handle space flights. But the research showed that older people can actually cope better with all this gravity craziness. So even if we don't develop space tourism in the next decade or two, you'll still have a chance to visit space even when you get old. Right now, there are two big players in the suborbital spaceflight game: Virgin Galactic and Blue Origin. Both of these companies have rocket-powered systems that can take up to 6 passengers on a thrilling ride. Virgin Galactic has already had 4 successful flights, but they recently ran into some financial trouble. On the other hand, Blue Origin has flown 32 passengers on their new Shepard rocket. The catch is pretty obvious. Right now, space tourism is super expensive. Companies can charge a whopping £350,000 per seat for these flights. But don't worry, things are about to change soon. Experts believe that space tourism will grow in the coming decades. It will be kinda similar to what happened to airplanes. Right now, the cost of a quick trip to space is very high. But as time goes on, the prices will go down. Eventually, space tourism will become more affordable and accessible to people all around the world. That means not just our children, but many of us will have a chance to experience the wonders of space. As technology advances, we might even be able to plan rocket-powered holidays in the future. Can you imagine telling your friends that you went on a vacation to space? What a flex! And now, let's talk about orbital spaceflight. This is the real deal, where you get to spend more time in space. Instead of just a few minutes, you can spend anywhere from a few days to over a week up there. And we're not talking about a measly 300,000 feet anymore. We're talking about going over 1.3 million feet high. So whether you're up for a quick jump into space or a longer adventure orbiting our planet, space tourism has something for everyone. Sky is no longer the limit. But space tourism isn't all fun and games. There are some challenges we need to consider too. First off, let's talk about the environment. Launching spacecraft and rockets takes a lot of energy and can create air and noise pollution. This can seriously harm our atmosphere. We don't want to trade a cool space trip for a damaged planet, right? Next, there's the issue of safety. Space travel is still risky, and accidents can happen. Even with safety protocols in place, there's always a chance of something going wrong. And if it does, the consequences could be really, really bad. Yikes! Space debris is another concern. Every time a spacecraft is launched, it leaves behind debris that can stay in orbit for a long time. As more launches happen, the amount of debris keeps growing. This can cause problems for other spacecraft, and even small pieces of debris can cause damage. Space travel also requires a lot of resources like energy, fuel, and materials. Using up these resources too quickly could have long-term consequences for our planet and future generations. We need to make sure we're not depleting everything in our quest for space exploration. Oh, and let's not forget about all the legal stuff. The rules and regulations for space tourism are still evolving, and it's not always clear who should be responsible if something goes wrong. Plus, there are concerns about how space tourism might affect international space laws and treaties. We don't want legal chaos in the final frontier. And finally, to achieve our dream of taking spaceships like planes, we'll need better infrastructure and logistics. We'll need to build more spaceports where spaceships can take off and land. But don't worry, scientists are actively working to solve these problems. Remember, it's not just us who are excited about space tourism, even governments are joining the fun. Many countries are investing in space tourism too. It's a global phenomenon. So even though there's still a lot to develop in this industry, it's pretty obvious that the aviation industry might go through a big revolution. Traveling long distances would become much quicker and more exciting. And judging by the way development is going, the first big breakthrough in this area will be made in North America. So, get ready for a new era of travel. What an exciting time to be alive, right? The universe is calling, and it's time for us to answer. Stay tuned!
Traveling to space costs a fortune, but there's a way to make it affordable. You step into an elevator, push the button, and voila! You're flying to the stars, all thanks to nanotubes. But then something hits the elevator on the way. You're stuck inside, and now you're doomed to float in space forever. Now, if you want to travel in space, get ready to shell out around $55 million. But in the near future, you'll probably be able to travel to space with just the push of a button without breaking the bank, because space elevators might come into play. While the idea of galactic lifts seems like something out of a sci-fi movie, it is a real possibility that could revolutionize space travel. With an estimated cost of $8 billion, space elevators could be a one-time investment that would last us forever. NASA alone spends around $2.7 million on rocket fuel per minute. To launch a rocket, they need to pay up to $178 million. These costs could be significantly reduced with the use of elevators. Most super tall buildings on Earth have a massive foundation to help with their balance and weight. As you look up, they get thinner and thinner. Even the tallest building in the world, the Burj Khalifa, is massive at the bottom and narrow at the top. If we wanted to construct something like a gigantic lift, we would need an enormous amount of concrete to build a foundation for it, which goes against the point of saving some cash. Now, get a string, tie a ball at the end of it, and start spinning it. The string in your hand will stay in one place, and the ball will revolve around your hand. This is called centrifugal force, and the elevator will work in the same way. The ball will be the base in space, and the rope will hang toward Earth. The station from where we would enter the elevator would be in the middle of the Atlantic Ocean, and the line would extend from there. For this to be possible, the line must be perfectly synchronized with Earth's rotation. Otherwise, it would simply break or wrap around the Earth like a scarf. Also, the orbit the line would be following should be a perfect circle, because the line wouldn't be able to get shorter or extend. A bunch of research has been done using algebra to find the ideal solution. Wait a second, there's a use for algebra? Never mind. Meanwhile, I won't bore you with the math. We'll go straight to the point where the precise distance from the station in the Atlantic to the one in space must be 22,236 miles above the Earth, where the geosynchronous orbit starts. There, the four outward forces are much stronger than the downward force. That's why the station would stay in one place. When you construct a house or a building, you start from the bottom going up. But to create this engineering wonder, we would need to do everything in reverse and start at the top. The main problem here would be the weight. If the line was too heavy, it would disrupt the orbit, and the conveyor dumbwaiter host would not work. So, we need to balance the station in space to ensure it worked flawlessly. Steel is one of the most robust materials on Earth. The cable in every lift is made from steel. But when you need a 22,236-mile-long cable, things can get tricky. Steel is hard to break, but it's cumbersome. And when you have to use a lot of it, problems start to arise. We use heavy steel a lot in construction, but we have lighter materials that might put less stress on the station and eliminate this problem. Also, the line would have to be tapered because, at the endpoint, there would be close to zero stress. But it would still have to be thicker than really needed due to a bunch of safety factors. At the start, the rope would be around 0.5 inches. After using some complicated math, we can figure out the thickness at the end, which is a number so long I am unable to pronounce it. But believe me, it's a big one. So, steel is off the list. Another candidate is Kevlar, which is 5 times stronger than steel. And if we added such materials as carbon and titanium into the mix, the strength would increase tenfold. The line would have a diameter of around 262 to 557 feet. This is drastically smaller than the diameter of the steel cable could be. The bad news is that doing this is too pricey. So, if we don't find the ideal medium to build a cable, the idea of the space elevator will just be a massive waste of time. If only we had some magically light material with a power of 60 gigapascals, which would have a taper ratio of 1.6. Oh wait, we actually do have this unique material. It's called carbon nanotube. It has a strength of 130 gigapascals, which is much more than we need. Nanotubes are made out of carbon and are 100,000 times thinner than a human hair. This material is solid and has good conductive power, which is possible thanks to its unique atomic structure. We use this product in many things, from batteries to optics, and it can be modified entirely and adapted for more uses. Bradley Edwards is the guy responsible for this crazy idea. NASA was looking for new innovations, and they said, "Don't do anything too crazy and start building a space hoist." I guess Bradley took this as a challenge and started working on the elevator. Edwards wrote a paper about a galactic conveyor. When he published it, he expected many people to find flaws in his work, but surprisingly, nobody did. His work was spot on. He came up with the idea of strapping a nanotube line to a rocket and launching it into space. The other end of the rope would fall onto Earth, and robots would use this rope to climb up and make it longer, so we could start building an elevator space station. After this, the elevator could start transporting everything, from solar panels to tourists. In the future, space tourism could be totally possible. Who knows? We might even go on vacations in space. Hey, looking for some atmosphere for your getaway? Well, don't come here. We don't have any. Oops, probably not a good advertising slogan, huh? Meanwhile, a couple of years ago, we could only create microscopic carbon nanotubes. But as time went on, much more research was done to make them bigger. Now they reach up to a few inches. In 20 years, they could be miles long. Carbon costs $28 per ounce. If we do the math, we would see that we would need around $1 billion to build a lift. Yeah, it sounds expensive, but it's a long-term solution to space travel, and it can actually save us a lot of money in the long run. Now, everything looks perfect on paper, but NASA's main reason why they chose not to go along with this project is that right now there are probably more than 128 million objects floating in orbit, and they might pose a real threat to the elevator. The lift could be made to withstand a few hits now and then, but getting hammered non-stop is not part of the plan. Still, Bradley argues that tons of monitoring devices track space debris. Thus, the elevator could avoid them all. Now, if something hit the elevator or the line somehow broke, the consequences would not be too bad. If there were no passengers on board, of course. If the line got cut, the elevator would simply float away into space, posing no threat to people on Earth. In Japan, engineers are trying to build a space elevator. The lift could be used for space mining, too. We could easily cover the cost of the entire elevator by collecting asteroids, because some of them are made of expensive metals. We could mine them and quickly bring them back to Earth. Now, in the 70s, we received a radio signal that lasted more than a minute, and to this day, no one knows what it was or where it was coming from. But now, a new theory has appeared. Could the mystery finally be solved? In 1977, at 11:16 p.m., a telescope in Ohio caught something very unusual in space. It was a super short radio signal, just 72 seconds long. The signal was so strong and weird that the scientist who found it wrote "Wow" in red ink next to it. That's why it's called the WOW signal. Now in space, hydrogen gas sometimes releases radio waves, a type of electromagnetic radiation. They emit at a specific frequency, which is like a unique signature for hydrogen gas. This helps us to find, identify, and study it. Thanks to this, we noticed that the WOW signal frequency came from the same place as this gas. But it's not like it helps much, because we still have no idea what emitted it. What's even stranger, the signal happened only once. Even though we tried really hard to hear it again, we never did. And without a repeat signal, it was impossible to tell what it was. It's hard for us to even get its precise location, because the signal was short-lived. After a certain distance, it's very hard to tell where different radio signals are coming from. And that's where the theory started. This particular frequency that the WOW signal was on is special. It's not crowded with a lot of other signals. It's like finding a quiet spot in a noisy room. Because there's not much interference or noise, so if you send a signal on this frequency really far, it won't get lost or distorted. And that's curious, because it means that there might be a perfect place to send messages if we want to communicate with any extraterrestrial creatures out there. So, could it be that they're trying to contact us? Well, it's a real scientific possibility. No one knows for sure what caused the WOW signal. But if it was from something extraterrestrial, they definitely communicate not like we do. The signal looked nothing like a deliberate message, and that's weird that it happened only once. If it was little green people trying to contact us, it would be weird for them to only try once. But just in case, in 2012, on the 35th anniversary of the WOW signal, we decided to send out a bunch of messages toward certain stars. We used a special code to make sure any extraterrestrial creatures who got the messages would know they were from intelligent beings like us. Well, mostly intelligent. We even used a lot of power to make sure the messages could travel really far. Scientists have come up with lots of ideas about where the WOW signal might have come from. but none of them are widely agreed upon. We know for sure that it didn't come from anything on Earth. Earth noise can interfere sometimes, but this signal definitely came from outer space. There was also a theory that the signal might have bounced off some space junk and come back to Earth. But later, we realized that the requirements for that to happen were very unlikely. One potential idea is that the signal might have been caused by twinkling in space, like how stars twinkle in the sky. But even if that's true, it doesn't rule out the possibility that the signal was made by something artificial. Another idea is that it could have come from something spinning, like a lighthouse. Or maybe it was a signal that changed its frequency over time. Or it was just a one-time burst. It's been 50 years since a strange radio signal was caught. But recently, a new idea about its origin sparked up. Now, imagine a comet streaking through space, leaving a trail of gas behind it, like a tail. This gas could be key to understanding the mysterious radio signal that caught astronomers' attention all those years ago. One of the astronomers looked at the WOW signal and thought it might be connected to a comet called 266P/Christensen. Yeah, that's a mouthful. This comet is about 1,800 light-years away. It wasn't known back in 1997 when the signal was first detected, but now it could explain the strange radio waves. Comets can emit radio waves as they get closer to the Sun. It's like the gases around them start buzzing with energy. This buzzing might be what the WOW signal was all about. To test this theory, we used a radio telescope to listen for radio waves from other comets. We found that some comets did indeed emit radio waves at the same frequency as the WOW signal. Then we pointed the telescopes at this particular comet as it passed through the same part of the sky where the WOW signal was detected. The comet's radio waves could match up with the signal, and while the comet wasn't exactly in the same spot as the signal, it was close enough to feel like we were onto something here. It also might have been caused by hydrogen clouds from two comets, the ones we mentioned and another one called P/2008Y2. Who picks these names? But not everyone is convinced by that idea. Some say that the theory about two comets causing the signal doesn't add up, because comets don't usually emit radio waves in the ways needed to explain the WOW signal. Also, the signal didn't repeat itself, and only happened once, which is weird if it's really a comet. They spread out their gases over a large area, so the signal would have lingered longer. The telescope used to detect the signal should have picked it up twice in a short time span, but it didn't happen that way. Also, the comet wouldn't have moved out of the telescope's view so quickly. This shows that we need to learn more about how and why comets emit these radio waves, especially at the same frequency as the WOW signal. There are also a lot of mysterious and interesting signals in space. Most of them come from natural events, like something called fast radio bursts. These bursts of energy are incredibly powerful and occur all over the sky, but their origins are still unclear. They last for only a fraction of a second. Maybe the telescope caught just a part of one of these bursts. There's also a strange signal we've been receiving since 2018. This one actually repeats every 22 minutes, but despite our efforts, we can't figure out where it's coming from. It started way back in 1988, and we've been investigating this mystery for 36 years now. At least here we know the distance of the mysterious object sending the signals, a distant 15,000 light-years away. Some speculate that these signals could be from extraterrestrial beings trying to communicate with us. However, we can't say for sure without solid evidence, so it remains speculative. Another explanation is a pulsar theory. Now, pulsars are neutron stars that emit beams of energy, similar to what we've been observing with the signals. However, the behavior of the signals doesn't perfectly align with what we know about pulsars. There's also the magnetar theory, suggesting that these signals could be coming from supercharged neutron stars called magnetars. Yet, none of these theories fully explain the strange behavior of the signals. Maybe there's a new, undiscovered phenomenon in the universe. So even though comets are a possibility, There are still a lot of unanswered questions about the WOW signal. We don't know what caused it, and we may never know. We don't even know if it came from deep space or from somewhere inside the solar system. In any case, even if the WOW signal had a natural cause, it doesn't mean that extraterrestrial life doesn't exist. The study that talked about this also discussed a sun-like star that could be a great place to look for signs of technology from space. There are 14 more stars similar to our Sun in space, although we're not totally sure about their brightness. This opens up exciting possibilities for hunting down signs of advanced civilizations beyond Earth. Ooh.
Ladies and gentlemen, this is your captain speaking. We'll be ready to take off in 3, 2, 1. Living on a spaceship sounds like a sci-fi movie topic, but gradually turns into a plan for the distant future dream. Let's imagine how it would be. Without further ado, I'll start with the light. On Earth, thanks to the atmosphere, the sky scatters the sunlight, so we get light in different directions. Then there are shadows, contrast, and ambient light. In a spaceship, however, there's no sky to create that cool ambient light. When you're in a spacecraft inside a solar system, one side of the ship can be lightened by the sun or another star, and one side can stay in the shadow. You can think of it as the crescent moon. If your spacecraft manages to go far away from any solar system, you might say goodbye to the bright side of the ship. You would be very far from all stars, so the ship is going to fly in the deep darkness. Don't worry though, the advanced technology will probably find a way to imitate the sunlight. Maybe designers will place LED light panels similar to windows, and inhabitants of the ship wouldn't notice the difference. What about people? A study revealed that a crew of 160 people could create a viable population for 200 years. Here, the important thing is to select the crew members from a large gene pool. No two passengers should be closer than 6th or 7th degree cousins. This is a projection from our day. Who knows, maybe hundreds of years later, whole countries will live in a spaceship. Your neighbor country in the world will be your neighbor in space. This reminds me of the scene from Thor Ragnarok, when the Asgardians who survived Hela escaped with the Grandmaster's ship. They went to Earth to settle down. Maybe we would go to Proxima Centauri b. It's an exoplanet, which is the term used to define planets beyond our solar system. Proxima b is in another star system, and some scientists do believe it has the potential. Some of them believe that there's a possibility that liquid water exists on the surface of a planet. It's important because this planet is our nearest neighboring exoplanet. Yeah, the nearest one, but it's almost 25 trillion miles away. To better understand this proximity, I'll give you a comparison. Currently, one of the fastest spaceships, called New Horizons, goes a whopping speed of more than 30,000 miles per hour. But even with this speed, it would take thousands of years to get to Proxima b. Let's hope we figure out how to warp the space-time equation by then. If I'm realistic, the first option is more likely. Let's assume we made a trip with our fastest spaceships. This would still be a couple of 100-year journey. This leads to another minor problem: the lifespan of humans. The same crew cannot make it to the end of the ride. Here, generation ships shine as a solution. A community of adults enter the ship, then their children, and their children. You know, until humanity finally reaches the new planet. There are two other alternatives. If researchers somehow made a way to make people live for centuries, we wouldn't need generation ships. Similarly, there could be a system to freeze people. It'll take 20,000 people to start a healthy population on a new planet. For now, I want to stick with the first scenario. Here's how it would be to live in a generation spacecraft. Dating wouldn't be as romantic as it is on Earth. There's probably a geneticist who will regulate reproduction. Freedom of choice in general would be decreased. The rules will be strict. In every generation, there should be certain tasks to manage. Someone should be a doctor, and someone else should be a plumber. New generations may go under a career planning test. Everyone would be assigned occupations based on their merits, aptitude,
passions, and available jobs. It reminds me of Snowpiercer, but hopefully things would go humanely and better in this version. People all need water, and they'll create waste. By then, maybe we wouldn't rely on plastic. Plus, recycling may be on another level. Still, we will need water. A healthy human needs almost 300 gallons of water per year. It's not like they'll stop by on a planet and refill the water reserves. So how can spaceship residents solve this problem? There are already systems to recycle some astronauts' waste into pure water. The next issue is infirmary. A spaceship might have almost no bacteria or microbes. People need them for a stronger immune system. If they get too isolated and land on a planet, they may have difficulty coping with the potential conditions there. Shielding carries importance too. Deep space is a radioactive place. Our planet has a magnetic field that protects us from DNA frying waves. Out in the open, the spaceship will need a strong shield. Maybe we'll be able to create some sort of force field. NASA is working on systems to grow plants in space. We will probably see special sections dedicated to farming and livestock. I also feel like this type of ship would also carry flora and fauna samples too. Who knows, maybe there'll be specific parks and different mini ecosystems. This would be great for the sanity of people on the ship. I mean, it's great to maintain the existence of the human race, but existential crises can mess with the passengers. They can eat their space sandwiches in the park and relax a bit with the sound of tweeting birds. Not just a garden, the young passengers might need a playground and school. Well, in this case, cabins, to get an education. They'll probably have a whole new curriculum, How to Stay Alive on a Foreign Planet 101. By the time we have this ship AI, and high-tech robots will probably be more popular than ever, there might be self-propagating robots. We can send these robots to our potentially new planet first and see how it turns out. We can even send robot teams to multiple worlds and see which one has a better habitat. I admit, generation ships look like an idea derived from Hollywood blockbusters, but there's an initiative called the 100-Year Starship Project. Mark G. Millis, the founder of the Tau Zero Foundation, is one of the participants involved in this project. They designed a probe named the Icarus. It has the theoretical capability to accelerate to 1/10 or 1/5 the speed of light. Although the current design of Icarus is not particularly sleek, resembling a skyscraper-sized behemoth composed mainly of rows and clusters of spherical fuel tanks. Millis explains that it's not a definitive representation of what an interstellar craft may look like, but rather the design that makes the most sense to build initially. When it comes to designing starships for humans, gravity is a key consideration in preventing the erosion of bone and muscle density. The solution is to create gravity with a rotating cabin or centrifuge, but it must be large enough to consistently simulate Earth's gravity to avoid disorientation and other health issues. Is there an arrival plan? Assuming that we land to Europa or Proxima B, the crew and the passengers need to be prepared for different scenarios. There should be equipment to scan the territory, or even self-defense gadgets to protect themselves from potentially hostile life forms. Once they successfully arrive, they need tools to build their homes too. When they finally arrive at their new planet, they might start advanced technology to travel around other planets. Hi Mom, I brought you a rock as a gift from the surface of Mars. There could be new occupations and a live space travel guide. And we might need some type of document, like a visa, to enter other habitable planets. There's a meteorite rain expected, so stay at your base for the next 2 years, says the newscaster. Okay, I'll calm down here. So how would you picture a vessel capable of ferrying humans from one solar system to another? Would it have some sort of wings, or would it look like a rocket? Tell me more about the design in your mind.
Picture this. You're an astronaut, hurtling through the cosmos in your state-of-the-art spaceship. But suddenly, you notice that you're running out of fuel. What are you going to do? Trapped in the middle of space. It's hardly like there's a floating gas station. The good news is that you're not going to get completely stuck. A spaceship will never actually stop after running out of fuel. All because there's basically no atmosphere in space. That's where the popular phrase, "in space, no one can hear you scream," comes from. Sound travels through the vibration of teeny tiny atoms and molecules. In space, where there is no air, there's simply no way for sound to travel. It's the same for our spaceship. Because there's no air, there's also a complete lack of air resistance. Those tiny particles that do exist in space are way too small to reduce the spacecraft's momentum or drag it back. Because of this, most spacecraft actually turn their engines off for the biggest part of their journey. So, don't believe those movies that show spaceships with their engines on all the time. That's completely inaccurate. Unlike vessels in the water, a ship in space doesn't need constant thrust to keep moving forward. Usually, its engine is only fired up for short periods of time. This is not only practical, but also saves money. Fuel is really expensive to transport into space as it's heavy. That's why space probes try to use as little fuel as possible. They need it when they set off from Earth, and then again when they re-enter the atmosphere. It happens when they need to slow down upon their return. While cars and trains have brakes, it's not that simple to bring a spaceship to a screeching halt. The engines are needed to slow the ship down or bring it to a complete stop. This involves strategically firing up impressive thrusters at the front. It creates the needed drag and reduces the spaceship's speed. But this process also requires super high levels of precision. One wrong move and you're toast. Literally. Hit the thrusters too fast and the spacecraft will set on fire as you re-enter Earth's atmosphere at thousands of miles per hour. Traveling too slowly can also cause problems, because in this case, you might miss our planet's orbit completely and move way past Earth. And most spacecraft don't have enough fuel to try for a second re-entry, so traveling too slowly needs to be avoided at all costs. But back to the issue at hand. This basically means that any vehicle with an empty tank will continue traveling at the same speed across space until it eventually runs into something. There's just no other way for it to stop. Wait, actually, maybe that's not good news. If you get stranded, it's pretty unlikely that your buddies over there at NASA are going to organize a rescue mission. This sounds kinda sad, but it does make sense. By the time they set up a new team and find a ship to come and rescue you, you'll have already traveled so far into space it would take them years to reach you. This would also cost a ridiculous amount of money. NASA spends on average a whopping $152 million to launch a ship into space. That's as much as buying 6 brand new top-of-the-range Lamborghinis. Even crazier, it cost NASA about $49 billion to develop and launch the first space shuttle. Unfortunately, once you've left Earth's orbit, it's near impossible that you'll make it back without fuel. That's what actually happened to NASA's Dawn spacecraft back in 2018. On a random day, the spaceship ran out of fuel. This left it completely stranded in the middle of space. It stopped transmitting signals to Earth, bringing an end to an 11-year-long mission that set loads of space records. The spacecraft could no longer generate electricity, as it had no fuel to move its solar panels to point them toward the sun. And to this day, the spaceship is still floating somewhere in space in a derelict state. Luckily, Dawn had no astronauts on board. The spacecraft began to orbit the dwarf planet Ceres, which was the object it was originally investigating. For context, an orbit is a curved path around a star, planet, or moon that an object gets stuck in. But wait, NASA are experts in all things relating to spacecraft. So how did they allow a ship to run out of fuel in the first place? It's actually super difficult to accurately measure the amount of fuel you'll need in space. On Earth, gravity keeps all the fuel at the bottom of the tank, and you can use a float sensor to measure how full the tank is. But this is impossible in space due to a lack of gravity that normally weighs the fuel down. Instead, a common approach is to add an air bladder into the fuel tank that's pressurized before launch to push the fuel into lines. The more fuel is used, the more this bladder expands. It takes up more space and keeps the fuel under the right amount of pressure. This pressure is monitored. That's how they can tell how much fuel is left. As you see, it's a lot more complicated than here on Earth. But say there were astronauts aboard a spacecraft that had run out of fuel. How long could they survive? Well, this depends on how much food and water is on board. NASA usually calculates the extra amount of food astronauts need for their trip to avoid adding extra weight to the spacecraft. But the good news is that this food can technically be rationed, and its consumption can be spread out. That's because astronaut food comes in special packaging to stop it from going bad. There are no refrigerators aboard spacecraft. The food comes in clear, flexible pouches that can be snipped open with scissors. All the food is pre-cooked and processed, so it doesn't need to be stored in a fridge. The only exceptions are fresh fruit and vegetables. These are the only things that need to be eaten quickly, as they will spoil. Today, astronauts also work with nutritionists so they can pick out the foods that they like and will enjoy eating. They can choose from a whole bunch of products, including mushroom soup, macaroni and cheese, chicken, beef, ham, nuts, and even yummy cookies. Shrimp cocktail is apparently a new favorite among astronauts because of how spicy it tastes. Flavored drinks also come in powdered form, just like the Kool-Aid or instant coffee packets you have sitting in your kitchen cupboard. Interestingly, astronauts often report not feeling hungry in space, so it may be easier than you'd think to ration the food. But even if you can make your food last, what about water? Transporting anything into space costs a lot, and water is quite heavy, so it costs even more to transport. For this reason, tanks of water can't be constantly shipped up to space. Instead, astronauts have a really complex water system. It squeezes every last drop of safe and available liquid out of the environment. This involves recycling used water. It means that our buddies in space drink water that's been filtered from old shower water, their breath, the spaceship's fuel cells, sweat, and so on. But don't worry, such water is safe to drink, and it's actually even better than most drinking water that comes out of taps in the US. The water on a spacecraft first goes through a bunch of filters, starting with one that removes particles and debris. Then it passes through multi-filtration beds, containing clever substances that remove impurities. The final stage gets rid of harmful compounds and destroys nasty bacteria and viruses. There are also water reserves in case of emergency. For example, the International Space Station keeps around 530 gallons of water in its reserves, just in case. But what about the air supply? The primary source of oxygen on spacecraft comes from something called water electrolysis. This is an amazing system that uses electricity from the craft's solar panels to split water into hydrogen and oxygen gas. But as we saw with NASA's Dawn, without electricity, it's pretty difficult to aim the solar panels at the sun, which means that the oxygen system would likely shut down. There is some oxygen stored in a pressurized storage tank, though. This is a backup supply designed for emergencies, so it's not all bad news.